Bridget, we'll start with you. Just need one quick second to get everything set up. But you're up first. All right, Bridgerino. Yeah, sure. Actually, let's do this. This probably makes the most sense. Okay, says Manuel is going hiking with his GPS device. The marker on the trailhead says his current elevation is 174 meters above sea level. The next marker he passes is now 210 meters above sea level. As GPS says, he's gone a horizontal distance of 1 kilometer. You're welcome. Delaney! You're leaving early today, apparently.
Thank you.
And then it asks, what is the average angle of incline for Manuel's hike? So let's draw ourselves a little picture of this situation, yes? I think after you've got the picture, the rest will be pretty trivial. Okay. So here's our start. We're at 174 meters above sea level. So let's make this 174. Okay with that? We start walking, and we end here. And that is 210 meters above sea level. So that means that this part would have been 36, right? By that there, Bridge? Okay. It says we've gone 1 kilometer horizontal distance, so that side of my triangle is 1. And we're asked this average angle of incline. So that's going to be our theta. Okay? Now there's one little problem with what I've written down here. Anybody see the problem? Units! Yes! What's the problem with the units? They don't agree, yeah. So let's just convert kilometers into meters. So we can say theta then is tan inverse of 36 over 1,000. And then whatever that comes out to be on our calculator. I would be in degree mode. I assume that this is going to be represented in degrees rather than radians. Not that it was specific. I didn't ask for the angle to be in degrees, but I feel like that's the natural thing that you'd want to do there. Does that feel okay, Bridge? Yeah. You're welcome. So like it was weirdly, to figure out that other side was 36 was kind of the trick. Like, what do I do with this 174 and 210? I don't get it. But like you draw the picture the right way and it's like, oh, sure. Yeah, that's okay. That's the point of doing the homework, right? Is to kind of figure that stuff out. Leah! Okie dokie. Okay, standing at the top of your friend's 20-meter or 20-foot tall house. There's that. You notice a dog chasing a squirrel. So there's the dog. The angle of depression, or measure an angle of depression of 40 degrees to the dog. So here's the angle of depression. And an angle of depression to the squirrel of 50 degrees. So that's 50 degrees. How far apart are the two animals? Leah, you good with our picture here?
Yeah.
Okay. So I'm going to rewrite this here, doing a couple of things. So number one, oops. I'm going to use the alternate interior angles theorem to rewrite those angles in those spots. Is that okay? Remember that from geometry?
Yeah.
If you have two parallel lines crossed by a transversal, the alternate interior angles are congruent. So my parallel lines would be the line of sight and the ground. Right? That theorem? Okay. Anyways, that's what I'm going to use so I can rewrite it. You could have drawn the triangles like upside down with the line of sight too if you wanted, but that seems more natural to me to draw them this way. So I have this one, 20, 40. I'm going to call this side x. I shouldn't call it x. I'll call this one y. And then I have this one. That's 20 and 50, and I'll call this side z, where the relationship between, well, this is dog, and this is the squirrel. The relationship between y and z and x is that x is equal to z minus 1, right? So all I need to do is use tangent to solve for y and z separately, and then I can subtract and define that side x. Does that feel okay, Leah?
Yeah.
Is that enough to finish it up for you?
Yeah.
So we have tan 40 is equal to opposite over adjacent. Solve for y, and that's going to be 20 divided by tan 40, whatever that is. And then similarly, z is going to be 20 divided by tan 50. And then you just type that stuff through your calculator and subtract them. You know what I mean?
Yeah.
You're welcome. Amanda. No,
Is it from me?
from the homework set? Sure. Okay, so this is a vector problem, right? So it says a plane can fly at 600 miles per hour under its own power. If it's traveling at a bearing of 200 degrees, and there's a wind, 50 mile per hour wind at a bearing of 80 degrees, what is the plane's actual speed and bearing? So I see two vectors, v1 and v2. And the interaction of those is going to give the actual this plane's actual speed is there, right? So for vector 1, we have 600 miles per hour as our magnitude, and our direction is 200 degrees. So 90, 90, and then 20 more gives our bearing. So to convert that into an angle of rotation, 90, 90, and 70 more is 250. Okay with that? If I do the same thing for the wind, that's 50 miles per hour for the magnitude, and the direction is 80 degrees. So my angle of rotation is going to be here, oops, at 10 degrees. You good with that? So then I can resolve this vector. Our resultant is vector 1 plus vector 2. So that's going to be 600 cosine of 250 plus 50 cosine of 10, comma, 600 sine 250 plus 50 sine of 10. Punch that through our calculator to get the actual location of the plane. Just make sure I'm in degree mode, okay. I do that, I get negative 195.36. Oops. Gosh darn it. That's not right. I accidentally typed the wrong thing here. I'll go back and fix it in just this jiffy. Okay. So that's that. Amanda, are you okay to hear?
Yeah, I understand everything. The only thing that I didn't really understand was that, like, the plane was traveling 600 miles an hour, and then, like, what the 50 miles an hour would be.
So the wind is either going to speed it up or slow it down.
So why don't you do, like, 650, like, the other one? Like, why do you do 50 times 9 times, or, like, 50 times 10?
Because the wind isn't directly at the back of the plane. It's coming in at like an angle. So it's not going to push all 50 degrees or 50 miles per hour onto the back of the plane. It's only going to push it a little bit, or it's not coming directly at the front of it.
So you just, like, keep it, like you don't do anything with the 600?
Yes.
Okay.
Yeah. Well, let's finish it up because I'm sure somebody else wants to see the end of this. So then to calculate the speed, I'm just going to do the Pythagorean theorem with those two components. So that's 576.63 miles per hour. So the wind apparently was a little bit of a tailwind or a headwind, and it slowed the plane down a little bit, right? So if I go ahead and graph this, we're going to be 155 to the left and then 555 down. So we'll be like down here somewhere. So if I do my angle of rotation, my angle theta is going to be 180 plus that feet. which is always going to be tan inverse of the absolute value of Vy over Vx. So in our case, Vy is the negative 555 and the Vx is the negative 155. But we're taking the absolute value of that anyways, so it doesn't really matter. So I do that, and that is about 254.31, but this is then 74.31. And as a result, this piece is 15.69. So my bearing is going to be 180 plus that 15.69, or 195.69 degrees. And I guess you really don't need to find that angle of rotation to get the bearing out of it, but I just do it because it's something we're familiar with, and it's easy to then to get everything I need to get the bearing to pop out. I mean, all we really need is this number here to do the bearing, but, you know. Julia.
I have a question about so in there, it says
Let me read it real quick. You take a jet ski from a cruise ship that's anchored in a bay. You travel 60 knots at this bearing and then turn at that bearing and travel 55, blah, 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 from your position. How far away and in what direction is the cruise ship? Well, the how far away part isn't going to change, right? Whether, and the direction, so here's this. And then what did we do? We did a 345, so that's like over here for a little bit. And then we did a 230, which is like over here or something. So then this is our direction. It's still going to be the same because you're measuring from due north anyways. So whether you went and go and like do this or do this, they're like coterminal in a way. Oh, I'm sorry. Huh? Well, let's look here real quick. Well, the answer key matches if you just ignore that and you use the picture that I've drawn here. That answer will match. I see what you're saying, but I think you're thinking about it too hard. So what you're saying is you're like, okay, I took this point and I translated it to here. So it's like something like this now, right? And then I did this thing. Yeah, I mean, I think it's just a poorly worded question, is what I think is going on. Yeah, you're welcome. I don't mean to like hand wave at this and like brush it off or whatever. I see what you're saying, and like with that interpretation, I don't think you're wrong doing what you're describing doing, but I think it's just like reading too far into it. But yeah, it could probably use a little bit of revision to make it a little bit more clear what we're actually asking for there. So I agree with you in that regard for sure. Anybody else with questions from this? Or from these assignments? Again, we'll give you time in class to work on these in just a moment. Delaney?
Can you do number 6? I'm sorry, which?
Sure. Yeah, there's lots of 6s. That's okay. You place a giant balloon animal in front of your friend's house. To ensure that it does not blow away, you tie 2 cables to the top of the balloon and secure the tables on the ground at opposite sides of the balloon. Okay. So they're exactly 37 feet apart. And they are 55 and 62 degrees with the ground, and we're interested in H. Okay? So the thing you don't want to do is say that that this distance here is 18.5. That's definitely not right. That's only true as if you're dealing with an isosceles triangle, and based on the 2 angles that you have, you know certainly it's not an isosceles triangle because the base angles aren't the same. So let's call this one x. So this one would be like 37 minus x. And then we can just form a system of 2 equations and solve this, just like that last example that we did yesterday in the notes. So I can say tan 55 is equal to opposite over adjacent, and then tan 62 is equal to opposite over adjacent. No. But we're just, look at the sides that we have. We have the legs of the triangle. Like if they told us how long the wires were or something, like if there were, and we used 48 feet of wires, then like this would be x and this would be like 48 minus x or something. And then you'd want to use sine in that case because you'd have opposite and hypotenuse. But just most of the time that we're going to be you end up using tangent mostly because you don't get the hypotenuse very often in real life situations. Maybe if you're flying a kite and you knew how long the string was or something, you'd want to use sine or cosine then because that's would be the hypotenuse of the triangle you're making. But you'd need to know that distance to the object, which in real life you don't often get, or is difficult to measure anyways. Continuing on, so that gives me x times tan 55 is equal to h, and then h is equal to 37 minus x times tan 62, and then yada, 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 make my system and do the same thing we did yesterday in the notes. Is that good enough as far as the setup goes, Delaney? Can you take it from here? Oh my goodness, okay. So they're both equal to h, so I can set them equal to each other. And then we'll distribute things through so I can get the x's all on one side. So I'll add that tan 62 to the other side. And then both of these have an x in it, so I can factor that x out. And then we'll divide both sides by that quantity. And that'll be how we calculate x. And then now that we have x, we can go back and plug it into, say, one of the two equations, maybe that one, to find the height. And I'll let you plug those stuff into your calculators, right? So just algebra at that point. We did the hard part, getting the picture drawn. Isn't that weird that that's the hard part, and I say the algebra is supposed to be the easy part? It is supposed to be the easy part. You guys don't think that's as funny as I do, apparently. That's okay. It's Thursday. We haven't seen the sun all day. It's been kind of sad. Okay. So, if you guys would, if you don't have your tablet out already, if you could get that out for me and open up your OneNote to the content library. We're going to do our homework quiz here. So I've just pasted in homework quiz 4. I'm going to sync this notebook right now so that you should be able to find that there at the bottom of the content library here in just a moment. There's 3 questions on that homework quiz. When you finish those 3 questions in OneNote, you'll publish that OneNote file as a PDF and put it in the Dropbox for the homework quiz assignment that I'm making right now on PowerSchool. When you finish with that, you are free to work on whatever you need to for the remainder of our time together today. At that time, if you end up with any kinds of questions on anything, you are more than welcome to come up and talk to me. I'd be happy to address individual questions at any point for the rest of today. Any questions about that? Oakley dokley. So when you finish, you're going to turn this into PowerSchool. You'll find the assignment there active today for our calendar, titled Homework Quiz 4. If you have questions on anything, feel free to come and talk to me. Everybody cool with the plan? Okay. You probably knew that this was coming at some point soon, right? Had a feeling that today was going to be the day. You're hoping your feeling was wrong. Well, oh.